Alrighty, so this is our project number 2,
This being Scott Lerner and John Stanley.
and we are using debut video capture software that's now minimized. So, yeah, this is the mycall.c, and we have our first function, which is steal, which takes in the PID of a process. So when calling my get PID, we will get the current PID of our process, and then for all the processes listed, if our PID is equal to the current PID, then the user ID and the effective user ID will be set to 0, giving us root for that process. And yeah, that looks good to me. So let's check this out. So by calling this, we should see root access. Boom. Alrighty then. So let's scroll down. Alright, so now we have quad. Now quad takes the PID, and for all the processes, if the PID matches, it's going to set its time slice equal to 4 times its time slice, and yeah, so that's the code, and this is it right here. Looks good to me. Then let's go down to swipe.
Alright, so swipe. Alright, so here is the sys-swipe. This takes a target and a victim process, and it is supposed to take all of the time slice from the victim and add it to the target. So here we iterate over all of the processes to find the victim, grab its time slice, set it to 0, and then get all of the children of that victim, and then get all of their time slices and then set all of them equal to 0. And then after that, we iterate through to find the target, and then add all of the time to the target. Amplify takes a target ID or a target PID and iterates through the list, finds it, and then sets its its state to task uninterruptible and its exit state to exit zombie. And what that's going to do is essentially just have it as like a hanging process, and then you have to kill it manually. For this, we don't actually have we don't have a wrapper function that is really effective at showing it being a zombie. I can try and zombify. Actually, I'm not going to do that. I'm going to stop that out. Alright. So now we have sysmyjoin, and sysmyjoin is supposed to take in a PID, and then basically what we're doing is putting it in a wait queue, an interruptible wait queue, and then the process that myjoin gets called on in do exit will wake up myjoin from the wait queue and start it running again. And the code is not fully implemented. To do this, we had to, in sched.h, we had to add a wait queue head type, and then we were supposed to add in do fork a initializer for the wait queue, but upon adding that, it actually broke the compiler, and after getting help from the TA, we couldn't figure it out. So, yeah. And then, yeah, so the wait queue will be initialized here, and then the my join actually gets called, and then you call interruptible sleep on the current wait queue, and it'll add my join to the wait queue of the process. And then in exit.c for do exit, this is the wake up interruptible is how you call that on the wait queue, and that will wake up the next process, which happens to be the only process in the wait queue. But whenever I added the wake up interruptible, it broke warn on here, so I don't really know why it broke, but I couldn't get it working. So that also, after TA help, did not work. Let's see, what else is in here? Alright, so the last function is sysforceWrite. SysforceWrite is supposed to take, or essentially it's just supposed to be syswrite except without the permissions. So right now we have it essentially the exact same thing between syswrite and sysforceWrite. And we haven't actually gotten to the part where we change the permissions. And we think that that would actually be much easier, but at this point we can't get the code to run successfully. We can't get sysforceWrite to work, and also we can't get syswrite to work. The way we're calling it is something wrong. I asked the TA about it, but we couldn't figure it out. So let's see. Here is the definition of our system calls, all these, and the numbers that you would call them with.